I wrote a blog a couple of years ago about logging being better than using print statements. And it's really sad. Since then, I've written about 200 more blogs, but that's by far the most popular thing I've ever written. So, I obviously, a lot of people want to get beyond using print statements to watch what's going on in your program, but it doesn't seem like there's a good explanation. So this talk starts at the front door, and it goes as far as time allows. But I'm starting at the very beginning. The first thing you want to understand when you do logging versus print statements is print statements, you just say print some string or some object that has a string method. With logging, it's roughly similar with one extra little tiny wrinkle. You set the log level for the message, which you can get into all sorts of interesting discussions about what belongs at these different levels. But you're never going to get everyone to agree. But the important thing is you can say this is a debug message, this is an info message, this is a warning, error, or critical. And it's up to you to determine what that means. One thing that's interesting is you can say fatal and critical will be treated the exact same thing, and warning versus warn, same deal there. They're identical. Each one of these evaluates to a point score. I think debug is worth 10 points, info is 20, critical is 50, and you guys are clever, so you'll be able to guess the other two. Right, so that's the first thing to keep in mind. Log messages have levels. Right, so I wrote this really simple script. It's in the RGL subfolder. It's called Fun with Levels. When you run it, you say, here's the example of me running it. You say Python RGL, fun with levels.py critical. And then what that's telling the program is only show me what's critical or greater than critical, which happens to be nothing. Here's all the log statements that you'll see if you read the program. The text is not really important. The important thing is you see me typing logging.debug, logging.info. The important thing is what is that logging thing? That's just from me typing import space logging. Boom, you're done. So it's really not that hard to get started with a basic logging usage if you want to start using something beyond print. Logging.debug. This is what it looks like when you say, all right, only show me critical logs. Great. And you can say, okay, I want to see everything. I want to see debug. Right, so those are the two opposite extremes, and you can play around with the code yourself if you want to see it. So how does that work? How do I actually set that up? This is what you do. You do import logging. Let me just be happy to. You're going to import logging. You're going to say import logging.basicconfig, and you're going to tell me what's the level that is the floor. And then start sending messages to it. That's really all you got to do. A couple of things happen automatically for you if you take this sort of approach. The first thing that's going to happen is it's going to default to the standard stream logging handler. It's going to say, all right, I'm going to send all the messages that you give me right out to standard error. And I'm going to choose how to format them. The format is going to be the level, the name of the logger, I'll explain what that means later, and then the message you actually gave me. So going back up here, we see it says critical, root, I'll explain what the heck that means, and then here's the text. Not too much worse than using a print statement, I hope. It's not obvious what the heck this does for you either, but we'll get into that next. All right, so that logging usage was using the default handler of a standard error. Here's how you can do a little bit more stuff if you want to say, I don't want to write to standard error. Or maybe I want to write to standard error and other places too. We're going to use same logging basic config here. We're going to use the same level parameter, but then we're going to pass in file name. And it's probably pretty clear what this does. It says, rather than spitting it all out to the console, put it right here. Hit me with some questions, please, because I'm here to help spread the word. So here's an example, right? I run the program, nothing happened. Cat out the file, there it is. Okay, so by default, when you do this, there's an implicit parameter of how you open the file, and it's append, which means don't start with the file seek pointer at the top of the file, start it at the bottom. So every single time someone logs, just keep adding it to the bottom. So here I ran the program a bunch of times, then I catted out the log file. And there you can see redundant stuff. You can avoid that if you want to. This is one of those things where you really want to like pay attention to what you're doing. If you're going to be running lots of processes and they're logging to the same files, that's fine. Unix does a good job of that. But make sure that they all open them with append mode. Yeah, that sucks. I'll check the logs. Damn it. All right. So some downsides about this kind of approach of everybody appending is there's no indication of what program wrote each one of those logs. And you can easily imagine if this went on for a long time, you'd end up using up all your space on your file system. So later on, I'll get into explanations of how to format the information going out, and then also a couple of different techniques you can use to make sure your logs stay manageable. So that was all using logging.basicconfig. I never use that. It's just there for people to feel comfortable getting started, or maybe for like really trivial one-off scripts, but it's better to just go a little bit more complex. Here's a real-world use case that I use a lot. Almost all my programs have this set up. Everything goes to standard error. Debugs, infos, warnings, errors, criticals. I want to see it all. And then I also want to see all that stuff in /temp. On my laptop, whenever I reboot it, Ubuntu goes through and deletes everything in temp. So it's okay for this directory temp to have big old chunky files. Then, now for other stuff, info and greater, there's usually like 10 debug lines for every one info line in my code. Put all the info and greater stuff here. Can't see the end of that line. Let me wrap it real quick so we can see that. Sorry. It's just kind of a Unix convention to put, whoops, a Unix convention to put stuff in var log. When you create stuff in var log, make sure that you pay attention to permissions. That's not all that important. Another thing is when something hits a critical, whoops, I want them to go automatically to my email box, or usually it's like to the dev@domain email box, because I hate being the only one on call. And also, every message I want it to have these parts. So when people say, why don't I just use print statements? This is why you can't just use print statements, right? And this isn't even all that advanced. But when you just, when you get in the habit of using logging at the beginning, adding more complex handlers and stuff, it's no big deal at all. But when you've got all these print statements in your code and someone's like, well, can you email me the tracebacks? No, not easily. Yeah, I can. I just have to rewrite everything. So I wrote a program called Beyond Basic Logging. We'll go through that in a moment. Here's me running the program. Here's me catting out the temp log, debug. All right, this is not interesting stuff. You can't see it, but like something way over here to the right. Oh, maybe I have to like, you'll see the message if I do this. Sorry about this. Yeah, forget it. So I'll wrap these. The messages are way over here. You just have to use your imagination, I guess. Let me see if I can make the screen in my end. Well, I don't know how to mess with it right now. The messages are way over here because the logger formatter that I set up says, all right, very first thing you see is a timestamp, down to the very small fraction of a second. Then the next thing you see is the level. Then the next, that 10515 is the process ID. This is the file that contained that log statement. And then there's also, let me show you, let's see if I can figure out how to. There, that's what's on the rest of the line. That 78 is the line number on this file that generated it. And that's the log message, right? So nothing particular interesting here. Here I cat out var log. This is really me just proving to a skeptic that I'm actually doing what I thought. So you can see there's no debugs in here. All right, and then Let me hop over to Gmail. This is the message that I got. You can now see the same format. It's the exact same format for here too. Timestamp, log level, process ID, program, file number, message. Really nothing particularly fancy about this. So you guys want to see how that works? It's pretty straightforward. Okay, so you do import logging, and then you do, for a couple of things, we're using some fancy handlers that are not in the logging module. So you got to do import logging handlers. First thing we want to do is, just like we did earlier when we set the level, I want to say the root logger gets everything. Gets debug and everything else. This is how I defined those funky different ways to write out the message. A formatter is applied to the text that you spit in, or the result of whatever gets called stir on when you put it in there. And there's all these default symbols that you can take advantage of. This is not the full list. These are my favorites. Other ones include the thread ID, which is no use to me because I tend to quit jobs that involve using threads. There's a bunch of other good ones. Like you can say, oh, well, what's the module that this was in, right, as opposed to like, what's the file name? You can, go to package. You can do all sorts of kind of stuff like that. But these are examples. One thing that's kind of real small is, see how I'm doing like -10s, -6d? That has nothing to do with logging. That's just old-fashioned print stuff of saying set aside 10 characters or 10 column widths, and the dash means left justify it. So that's way it doesn't look all weird and crammed up together. So that's a formatter, real straightforward. Here's me explicitly making a stream handler. I don't say what stream I want it to go to. Let me push this up to the top. That means it goes to standard error. So sh is the stream handler. I'm setting the level for this handler to debug. I'm setting the formatter that this handler will use to be that formatter we defined up here. And then this last step, logging.root.odd handler sh means, hey, this is where it gets kind of funky. The logger root has a list of handlers that it knows about. When a message comes in to root, it sends that message to all of its handlers. Each handler can have its own logging level, and then each handler can decide what to do with it. So that's exactly what this example shows. But this is the first handler that I made. This is the first one that gets attached to the root logger. Let me stop for a moment. How do you guys feel about this? It's making sense? All right, good.
Where you have logging.root is root.
Yeah.
So I didn't see, did you set up logging.root?
No, that's a great point. Right. Where does symbol come from? .root. Right. It's built in. And yeah, so you see here, let me put my mouse on the line where he says, should I make this font size larger? No, you guys are good? Logging.root.add handler. Where the heck does .root come from? And the answer is that is defined already as a top level thingy when you import logging. I don't know, we could argue about whether or not that's Pythonic, but yeah, it's there. So when you import logging, you can immediately start playing around with logging.root. Way back at the beginning, in the very first examples, when we did import logging, logging basic config, blah, and then we just did logging.debug a message, what we were really actually doing was logging.root.message or logging.root.debug some message. That's the top of the tree for all the loggers. Later I'll get into an example of how one logger can have a parent pointing to another. But yeah, I'm glad you pointed that out. Right, so here I am. Now, so this first example up here, that was me setting up the stream handler. Everything goes to standard error. Now I'm doing the exact same thing, except I'm setting up a file handler, but really it's just, now I'm setting this file handler to be sending stuff to temp, use the same formatter, set the level equal debug, add it to the handler, boom, 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 we're done. And here I am doing the same thing for info. Only interesting part here is this level is info. Now, it's important to understand what this means. This means when a logger debug message goes to root, root will say, hey, here, handlers, have it all. this handler says thanks, but no thanks. I was told to ignore anything below info. I'm out. That's how we keep debugs out of var. Here's how we set up the email. Really stupid simple. I'm thrilled that someone made it so simple because this means there's really no excuse not to be sending tracebacks to yourself by email if you wish you could. It's just this easy. You just make an SMTP handler, you pass in this stuff. Here I'm sending it to the postfix mail server on my laptop. It's also, I've done it where I've used Gmail's public thing. You have to add in an extra parameter of your credentials, but it's, works just the same. It's just that easy. So here I make the handler. I set its level to critical. Let me scroll this up. I make the handler. I set the level to critical. If I were crazy and masochistic, I would set this to debug, and then every little debug message would be a separate email in my inbox. And that same boring formatter that I've been using throughout this program, here I'm adding it to the handler, boom, boom, boom. This is a convention. All that stuff was defined in a function I defined way up here at the top called configure logging. That's what I do. I make a function called configure logging, and then I just call it at the top level of any of my programs. Here's the me trying it out, and that's one way of configuring logging. It's fairly, which I think illustrates why logging is better than print statements. Oh yeah, Mike.
Can you set the formatter on the root logger itself so you don't have to keep repeating it on all of your handlers?
I don't know. It's a good question, but I know that formatters and handlers are sort of married. Like when you want to send something to a syslog server, the formatter might need to do different things.
Okay.
But yeah, it's a good question. And then yeah.
The things like your stream, the standard error.
Uh-huh.
Does that get just the debug message, or does that get everything, info and warning and critical as well?
You're setting a floor, and then you're saying everything from the floor on up, meaning debug is the floor. That means when you set logging equals debug, that means you're going to get warnings, errors, criticals, infos above. But there's a way, if you're interested in saying, no, I just want the debug, so debug and debug only, I'll get into filters later. Yeah.
Is there a way to set your own levels?
Like, I don't know. Yeah, I guess they would just be different numeric point scores that you're passing in, and it's just doing arithmetic. So, I guess, if you wanted to have different levels, but what you're really getting at, maybe, I'd be interested in talking more about like what you're after there, and maybe seeing if there's different ways you could dispatch your logs besides just using levels. Because I'll get into that later. You got several different dimensions on if you want to separate logs into separate places. Yeah.
Any number of criticals that happen within 30 seconds of each other or something?
Yeah, well, that's not something you could do in the logging, but in the, so he's asking, if I could paraphrase, he's saying, is there a way to take several different log messages and bundle them together so that they get sent out in one email? Because you can imagine if something's blowing up, maybe you don't need 10,000 messages of the same sort. Is that roughly correct question? Okay, so let me attack that by saying how I deal with a problem of, when I do a critical log is really you're just passing in some string. So what I do before I say logging.critical is I'll build a string that's very elaborate that maybe has like the traceback in it, that has everything I can think of, so that when I ship it off in one email, it has that single line, but then all that. What I don't know how to do necessarily without writing my own handler is to say, hey, I want you to grab nearby, like have a buffer, put all the messages in there, decide if they're similar enough to be glued together. It certainly sounds plausible, but the way I handle that is before I send a critical message out, I try to flesh it out a little bit more. Later on, I'll show how to take a traceback, put it in the logs, and that's something else you can do. There's some other hand up, I thought, but maybe I imagined it. Right, so we went through the results. I think you guys believe me that it's not a lie. You guys saw the email. All right, so that was I was using Python code to configure logging. And that's kind of cool, I guess. You know, I was making objects, appending objects to other things. I wrapped it all up in a function called configure logging. You could imagine that being in somewhere in the top of your source code tree, and then you just import that thing and running it. And that's cool. That's not the only way to do it, though. Code is the first way I learned how to do it. I live in IPython. That's where I actually do all my work. So I tend to use code more than config files. There's two other ways. You can use old school Microsoft .ini kind of style config files because they get run through config parser. And that's the next example. And the last one is the dictionary, which is the new kind of official way, which I think is a good idea. So I wrote a function called, a program called logging config example. It's really just basically the same thing. Now here's what the configure logging looks like. It says, go get the config file named simpleexample.cfg. It's in this particular folder, rgl.loggingconfigs. And here's the way you do it. Logging.config.fileconfig, path to file config. You're done. You're still forced to do this. You still have to load the config file, but at least now you don't see a whole bunch of elaborate Python code. This is a different way to do it. So what the heck is package resources? Package resources is a solution to, well, actually, let me stay focused on this for a second. Right, so when we run this thing, you'll see all the same logs. This is how you load it in. When you define, here's a snippet from that config file. Here's how, remember how I made the SMTP handler instance in code? This is how you do the exact same thing here. You fill out a section of the config file. You say brackets handler SMTP. And then this kind of thing, this always seemed like just some sort of like hacky solution to define args that then get passed into code. It just seems like, yeah, either turn this into configs also or give up. But never mind that right now. This makes sense to you guys, right? Yeah. It's not exactly rocket science. Here, I'll show you what the big config file looks like for a second. So the config file, this is a convention that I follow. Just a second, sorry. There you are. So I make a folder usually called, so this is what it looks like. You have to have certain sections defined. You have to have this keys equals root. You have to define, all right, well, what's the root logger going to do? I'm going to set the log level debug. These are the handlers that this thing is going to send every message through. Console, SMTP, temp file, blah, blah, blah. Blah, 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 blah. It's not exactly, anything. You can't see it, but the very bottom is where I define the console. Let me move it up to the top so you can. That's how I define the formatter. Really, it's almost just like the exact same thing without double quotes or single quotes around it. And then I define the class. And okay, so package resources, I just want to touch on that. So when you build code and you have a config file, and then you give that code to someone else, and then they've got the config file, there's a dilemma you face. It's like, well, where are you going to put in your code to look for the config file? And there's, you could say, oh, well, store the config file in /etc/r library. And that'll get the job done. That will work. But, then when two people are on the same box, they're inadvertently sharing the same config file. Maybe one guy has write permissions, the other guy doesn't, blah, blah, blah. Causes a headache. Certainly doesn't play nice, even if you're only one person on the box, but you have several virtual environment packages. And maybe you don't have write access to /etc. That's the downside about doing a hard-coded global path. But on the plus side, it's easy, it works. You don't have to think about it. The other problem, other kind of thing people do a lot of times is say, oh, well, you have to define an environmental variable, blah, blah, blah. And that's just a that'll work too. It's just a real pain when you're trying to use somebody's library and you realize you're not done when you think you're done. Now you gotta go and create all these other things. If you use Python eggs to deploy your stuff, Python eggs have a feature that you can say, don't ever put anything on the site packages except for a zip file. And then dynamically at runtime, Python unzips it into memory and accesses the components. It's really cool and fancy. It makes it dang hard to point to a file inside of a zip file because it doesn't work. So package resources is a thing out there. It's not in the standard library, but if you use easy install, you've already got it. If you use pip, you've already got it. It's probably one of the most popular packages out there. Package resources lets you put things that are not code into your source code tree, stuff like CSS files, images, in my case, config files, and then using something that sort of works like Python package imports in order to grab those things out. So in my case, I have a folder called RGL. I have another folder inside of there called logging configs. I could put Python code in there, but I instead, in this case, I put this simple example config file in here, and then when I want to access that dynamically through code, it doesn't matter if you've installed my package under /opt, if you're, home, mat, wherever you've put it, this will resolve to something that is a path name that is not like relative. This is going to give me a global path name. So it's one of those little nice to haves. Like a lot of times people do goofy things, and so I just thought I'd pass that along. We talked about code. We talked about using the old, config parser style. According to the docs in Python 2.7, both of those are not exactly deprecated, but they're not the new cool way to do it. The new cool way to set up your logging configuration is to fill out a dictionary, a Python memory dictionary object, and then give it to logging.config.dictconfig. And at first I read about it, I was like, that's silly. That's why wouldn't you just use code? And it makes a lot of sense when I realized this way they stop the war over XML versus YAML versus JSON versus proto buffers, blah, blah, blah. Now anybody can use anything they want. If they want to use a SQL database to store all their logging information, that's fine. They just need to write a little skinny layer of code that takes that, deserializes it into a dictionary, and then you're off. I think YAML is pretty cool as markup languages go. This is what the YAML data structure or the YAML file looks like that you could use to get to not exactly the same thing, because I just want to keep it simple. This is a real simple YAML config. It's real easy, or I hope it's real easy, to imagine how this gets turned into a nested dictionary. Version is a key pointing to 1. Root is a key pointing to a dictionary that has a key called level, and on and on and on and on. This doesn't follow the exact same structure as the .ini style config. In the .ini style config, you had loggers at the top, and root logger was a child of that guy. This is different. This is this is weird. You got root at the top. Later on, I don't define it in here, but you can also have other loggers, but root has to be a top first-class citizen. That tripped me up. Also, you absolutely have to have this version equals 1. That's the only allowed value right now. I don't really know what they're planning on doing with that, but yeah.
So headers, that's a string with square bracket on either side, right?
Oh, that YAML parses that into a list.
It does? Okay.
Yeah, that's why YAML is awesome. It's because a lot of times when you deal with like XML, you have to say, oh, well, when you see these symbols interpreted this way, like XML, if I say store somebody's birth date down to the second in XML, everyone in this room is going to mark that up slightly differently. Everyone in here, you guys, there's lots of interesting conversations about attributes versus elements. YAML has built-in support for date times. There's no ambiguity, it's just boom, you're done. So when you parse and write YAML, it's done. So it also has support for nested lists. So it knows, oh, you want a key value pair, and this is some sort of sequence. Now, YAML can be parsed into Ruby, into Python, into all sorts of other languages. And so it's up to the parser to kind of give that to the local language in some sort of native format. But in Python, it works just like what you want it to work like. It's going to load a string, a list of one element with a string in there. All right, so so I just ran into this thing real recently. It was like a stupid example. So Kaboom1 is a script. This is what it does. I'll put this at the bottom. Here's the main section of, I configure basic logging. I call this function f, I'm out. F doesn't do anything cool at all except call G, calls H, calls I develop, 1 by 0 kablooey. Right. This is typical for most of the code I write. So, so here's what happens when you run it. You get a traceback. Those are helpful. Those are good for debugging. Here's the problem. That traceback ain't getting logged right now because that was a uncaught exception that crashed Python, and Python is defined, it's configured to send the last, its last dying breath out to standard error, but it's not ending into the log. So if this was running on some remote server at the other end of a web service and I didn't have the ability to SSH in, I'm in a bad state. So here's me catting out the log file just in case you didn't believe me when I made that assertion. The first log statement went in there. All right, so how do you get uncaught exceptions that crash your whole program in there? People call this the diaper pattern, just because it's like, greedy, try and etc. on everything. And that'll work. That'll get the job done. A friend of mine, Mike Pernaut, wrote a pretty clever blog in analyzing kind of why we call it that and all that. I hate this because invariably you find people wrapping it around other wrappers and you just end up with this code where it's like, 12 indents in here and, everything seems to work right, but nothing's actually working right. And also, if you use tools to watch return codes of your programs, like to the operating system, if you're not real careful, you can accidentally obscure the real error code with one that says everything ended okay, unless you use that raise thing in there. The raise thing will at least try to pass it on through. That'll work. I don't like it. Incidentally, notice I did logging.exception here. That does not map to any of those 5 levels that we talked about. That's because really, logging.exception is the exact same thing, if you look at the code, is logging.error, passing in the exception, and then passing in this parameter excinfo equals 1. That tells the logging framework to examine this exception instance that's coming in right out of traceback. Incidentally, it's going to go in as a log message with score of 30. Maybe 30 is not good enough. Maybe since this was actually something that crashed the program, you want to say this is a critical class error, but if you just passed in exception here, it would call a string method on the exception, and all you would get is the text of the exception, which is never what you want. So you can say anytime you're passing in an exception, you can say take it apart and do stuff, show the traceback in there. All right. So if you're going to do it using excinfo equals 1 if you're going to use these diaper patterns, but don't do it. The way I suggest that you do it is take advantage of this sys.accept hook thing you can define in Python, which says uncaught exceptions go to me, but I don't catch them and block them from propagating. I just notice them going by. Here's a real simple one that I wrote. You don't get to control what the input parameters are. That's what Python calls with your stuff. Sorry? Oh, yeah, okay. This is the type of the exception or the class. This is the exception instance, and this is a traceback. And so here, this is an example of how you can get something in your logs that looks an awful lot like that traceback that you see on the console. You're going to use the traceback module. You have to import that. You say format it, which says send it out as a string, passing in the traceback. Then logging.critical, here's what I'm saying. I want to see the class of the exception, and I want to see the exception message. Earlier, you asked, how do you prevent so many dang emails to go out related to the same thing? This is an example. If I had a logging handler that was mailing these things out, this would send out 2 emails, but it's real easy to imagine that, well, this is just going to evaluate to a big old string right here, and so is this. So we could make a bigger string and log it once. You guys follow me there? So Python RGL kaboom.kaboom2 puts it in the log, and this is what it looks like in the log. Here I'm catting out the log. You see the traceback. You see the message. Notice that there's a critical message here and here, so that's why you'll get 2 emails. And you can verify for yourself if you want non-zero return code. All right, so now let's talk about going beyond logging to everything to root. Pretend you're writing Zork. If you don't know what Zork is, then you can look it up on Wikipedia. But I don't know why you're here if you don't know what Zork is. So there's 2 halves of your code. One thing parses the player command. Zork was a game where players typed in stuff, because that's what we thought was fun in the 80s. And then the next part of the program says, all right, given valid messages coming in from the thing that parsed them, let's update or reveal the state of the game world. Oh, and then there's a third part of my program too. I'm constantly pinging my central BBS saying, hey, is there any new bug fixes I need to apply locally? This is how I want the logs to work. There's 3 components of my program: the parsing layer, the data game state layer, and then this bug fixing thing, and I want to keep their logs in separate spots. You know, a debug message related to parsing, I don't want to associate with a debug message related to the game state. Here's a real simple example: boom, boom, and boom. One thing that I made this just a little bit jazzier is bug fix checks I'm going to pretend are real frequent, and I only want them to go to temp and, whoops, and I only want to see the most recent ones in temp. I don't want to risk temp filling up. So I want a cap on the size of temp, so that, you know, even if the program is checking 1,000,000 times, I don't flood my hard drive. And everything except for the bug. Oh, the last thing is I want parsing stuff and I want game state stuff on standard error. I don't want the bug fixes stuff. So 3 different sections of the program. 2 of them all go to standard error. Parsing has its own var file. Game state has its own var file. Bug fix has its own temp file. Here's me running the program. You can see on the standard error. Dang it, how do I make the screen visible so that you can see it? Sorry? I think here, yeah, that's beautiful, isn't it? Okay, so yeah, so you can see here multiple logging channels.py is I only wrote 1 program, but you can see line, you can see it says player command look. That's a message from the parsing stuff, and then you can see that this retrieving room description is from the game state logger. I'll show you how this stuff works inside next. And you don't see anything related to the bug fixing. Instead, all the bug fixing stuff is in its own library. And the other thing, it's all in this, the bug fixing stuff is all in temp. That's right, so how the heck does that thing work? Well, the first thing I want to do is, well, let's go to the program and I'll show you guys. Okay, so I wrote 3 functions. I bias my code towards simplicity at the cost of maybe stuff being really redundant. Do whatever the heck you want. That's just my style. The main thing I do here is instead of just you sending every message to logging.debug, this is the first time I've done this in this example. I'm saying logging.getLogger, give me a logger for parsers. And then you can see later here, later on you'll see me sending messages to that logger. Otherwise, this looks like the examples we've done before. Set a level, set a file handler, use my formatter that I love so much, set it up, blah, 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 blah. Okay, and then notice I'm not returning this thing. I'm adding it, I'm adding a handler for it, and then that's the end. I'll explain that in a second. So here I make a logger for the game state. I'm saying get logger game state. And then I configure it, and here's the bug fix checker. The only thing that's interesting here is that when I make its handler, I use this rotating file handler. I think this is kind of like a nice little toy thing to know about. You can set the maximum bytes and you can set the number of rotated files. So that means when it hits 800 bytes in memory, it'll immediately move, .log to .log.1 and open a new file. And since I've only keep 1, it'll only keep 1. You can set that equal to 2000 if you want to. And then here's me configuring the root logger. This is the root that we always use. Here I'm saying, hey, I want to know about all the debug messages. I send everything to stream. Okay, so formatter, blah, 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 blah. And now here I'm calling all those methods, and then I'm making new instances of what I'm logging to here. I'm saying game state logger equals logging.getLogger. Here's the thing. When you feed in the same string here, the first time the logging framework sees it, it creates something, and then it keeps references to it, so other program components can ask for that and get a reference to it. Quite literally is a reference, not creating a new object. You are just passing around the same thing. I think maybe I have an example if you don't believe me, but if not, try it out yourself. Do logging.getLogger ABC is logging.getLogger ABC, and you'll see they resolve to the same memory address. Okay, so here's me sending log messages, right? I'm saying debug, this is what the player did, this is what the game state did. Parser did this, game state parser, blah, 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 blah. And then you can't see it because projector cut off, but here's me simulating a crap ton of the bug fix checks. Me sending that message 100 times, that just shows example of how the rotating log file works. So the question the question is, remember I kept my bug fix logs out of standard error, and the reason why I was able to do that is because I said, hey, for the bug fix logger, set propagate equal to false. The root logger has these children. It has a bug fix child, the parser child, the game state child. Each one of those, when it gets a log message, it does what it's configured to do and then passes it up the chain. So I did not configure a standard error handler on the parser, but its parsing logs showed up in standard error because the parser took it, put it in its varg file, passed it up to its parent, parent put it in standard error. This is how you prevent one of the child things from sending its stuff up. Make sense? All right, yeah, like I was saying, log instances are recycled. Here's me showing my wounds to the doubting Thomas. Does this make sense? So in more realistic scenarios, you have two modules. Each module at the top says log equals logging.getLogger, some package name, and you're good. And here's an analysis of the rotating file handler. Okay, filters. Filters are another way of kind of grinding it out. Imagine you have a web framework. You want to send 404 errors to one file and 500 errors in another one. It's not so easy to do that. You're going to use the same level. You're going to be using the same logger because it's still, let's say it's the same section. So you can define what they call filters, which is something you attach to a handler, and it says you only handle these kinds of logs. The filter works on the log message, and a real simple way that I'm not exactly in love with is so here's what a filter looks like. You subclass logging filter, and you define a filter message, gets log reference, log records, and you can say, all right, well, if it starts with 404, return true. Then that will block the handler from getting it. Here you can see me saying, all right, setting up a handler, setting up the filter on that thing, and now that means when I run this logger, you only get this. I hate this. What happens if you log a message saying, something about like user ID 40409 showed up, and it's easy to forget to accidentally, it's easy to accidentally forget about this thing when you're using logging. So I don't like checking for substrings. If I'm going to use logging filters, what I'll do is I'll define classes and log the whole dang class as an instance. I mean, really, it's just a real fancy looking string object, really. But this lets me do type checking on this. So you can imagine if this is actually the object that's going to go out to the web server, you can imagine just sending this whole thing in. You don't need to log strings. You can log anything with a string message. So that's what I'm doing here. I'm instantiating response 404, sending it to my logger. And now let's look at what the filter looks like. Instead of saying, oh, did the string begin with 404? No. Now it says, is the thing that got passed in an instance of this response 404? Okay, great. Handle it in this particular way. I prefer this approach. It's kind of cool. You cannot use .any style config with this. This is a more, what was I saying here? Oh, yeah. It's a nuisance to have to make a filter, make a handler, connect them, marry them, all that. So this guy on this blog had a pretty clever idea. Just subclass a handler, that has it all built in together. I thought that was really good. Like I said, you can't use .ini style configs. There's no slot for you to find a handler filter, but if you need to use them, you just use your own subclass thing. Logging exceptions, not catching an uncaught exception, but how to actually log an exception. So I already showed you how to just dump the traceback out, but that's really only one of the things you can do. Here's the program that FGI, now I added a local variable x to each one of these things. Imagine if for whatever weird reason I was interested in getting the value of x inside of each one of these frames when it blew up. Here's a really ugly example, but you can see when the logger goes, this is what you see. That's the code. This is what the exception thing does. I'm just using some stuff to explore the stack trace. Here I'm iterating through it. There's all sorts of good stuff inside of here. I mean, I'm only doing a tiny bit, but you can see now how I'm able to access the locals in each one of those frames, and that's how I'm able to see the value of x in each one of these. So another thing is rotating log files. So I showed you guys how to rotate them in process. That's really not all that sufficient for a lot of cases. Unix has this log rotate facility. Here's a config file that I use all the time. This lets me rotate everything that's underneath var log RGL. I've only got 5 minutes left, so I want to go through this. The point is, this lets you do stuff like zip them, and then it also lets you define like a post rotate handler. In my case, for web apps, what I usually do is after rotating all the handlers, I'll restart everything so I know it's all ready to go. And I've also experimented with, at the point at which it's rotated, let's also use some sort of rsync thing to send all of the logs offsite at this point. Okay, syslog, that's sort of like the beginning, like that's the Unix logging system that's built in. There's a syslog handler built into the standard library. You can use it. When you log a traceback to syslog, this is what it looks like down here. It's gnarly. It flattens it. It replaces all the new lines with this thing. It's important to keep that in mind. So it's there. It's not all the pretty. Blah, 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 blah. Actually, I've only got 5 minutes, so I just want to stop and talk for questions. I'm going to be adding more stuff to this thing on GitHub, but I'm curious what you guys think so far. Is there any questions, or should I just keep going? All right, okay. Sorry? 2 minutes, all right. Graylog 2 is a pretty cool open source package that you can configure with it. They released a Python handler. This is me using it to capture my logs. This is what it lets you do. You say logging handler gelf. I don't know why, I think Graylog extended log format. And then you can get this, you can send them to their demo, which is what I'm doing here, or you can set up your own Graylog. It sits on top of Elasticsearch, so it's like two beta softwares combining power together. It's kind of cool. It lets you, do all sorts of digging in. You can do all sorts of reporting. There's also at least several web startups that are offering logging as a service. Loggly is one. It's kind of cool. It lets you, you set up syslog, and then it sends everything into it. The problem with doing syslog is that you're not just capturing logs for your particular app. You're capturing every process on your box that writes everything to syslog. Oh yeah, so last little soapbox. Privacy and security. There's two rules of thumb you should keep in mind when you're logging. One is pay attention to what you're logging. It's real easy if you're making a web app subscription flow to just get in the habit of just always logging everything, which is everything that comes in from the user, which is generally I think I can make sense out of that, but you might inadvertently write down customer credit card numbers on a text file on your web farm, and some other person might get real in a tizzy about that. Okay, so that's one thing. This happens frequently because people either log everything or log in a traceback. So be mindful of what's in your logs. Be mindful when you're sending your logs. If you send all that rich data by email, and somebody happens to have configured email to bounce to Gmail, you win. So figure out your risk tolerance, blah, 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 blah. Thanks for coming to the talk. I wish I had more time to talk more.
What you can do is go to the open spaces.
Oh, yeah.
Go to the open space, carry on.
Right on. Thanks. Yeah. Yeah. Uh-huh. The Python one. Yeah. My experience with the Python rotating file handlers is kind of a toy. Like the real one built into Unix, I've never had bad experience with. The one in Python, if it's doing a lot of I/O work to rotate big old files, well, that's going to compete for the CPU with your actual real-life program. And this is something to keep in mind anytime you start talking about logging centrally versus logging to text files. Is when you send messages over the network. When you send messages over the network, you are likely to, every once in a while, run into performance costs because you're flooding the network with your log messages. That's competing with everything else on the network. So there's lots of good things to consider there.
Oh, okay, sorry.
Thanks, everybody.
Well.
I get it.